Hello again. Uh, let's see. Nope. There we go. All right. We've probably heard up until now that there is a language in Condor called class adds, and that's true. But there's another language that we don't talk about as a language a great deal, and that is the language, for want of a better word, that we use for the config and submit files. This is a really quirky language, but it has some interesting and powerful features that I want to talk about now. By the way, this talk was originally given in Condor Week Europe 2018 in a 40-minute time slot. There is no way I'm going to finish it. But I left all the slides in place because the slides are very good and they mostly explain themselves. And so I will do what I have time to do, and then I'll get yanked off the stage. Feel free to download and read through. And if there's anything that you want to grab me and talk to me about in the break from the parts of the talk I don't get to, I'll be here all week. All right. So the config and submit language is essentially a language for building up a key value store that is short-term key value store that is used to control some part of Condor. In the case of the config system, it is used to control a daemon or to control Condor submit and the other tools. It's mostly used to control daemons, though, for the config language. This very same key value store building message is also used to create submit files or to describe submit files. So basically what happens, Condor submit runs, it builds the key value store, and then it uses that key value store to populate the class add that it's going to send to the schedule that represents your job. The key value store consists of essentially lines that are read from top to bottom. These lines will have one of two things in them. It will either have a key value assignment, which we recognize because there's going to be an equal sign on the line, or it has statements. Anything that doesn't have an equal sign on the line, it better be a valid statement, or at some point, the thing that's reading this is going to stop and say, yeah, I don't know what this word is. When we're populating the key value store, key value assignments are just read and used to store the hash table, but we don't do anything with this hash table. Statements are executed as they are read. Okay, because we're just loading key value pairs into this hash table, the last definition of a key is going to win. That's just the way it works. However, the schema depends on who's consuming this key value store. If it's Condor submit, then the schema is the submit language. And if it's the config system, then the schema is the specific daemon. Most daemons will look at a handful of knobs that are specific to the daemon, and then a double handful of knobs that are generic to all daemons. Okay. For the config system, sitting behind this key value store that we read from the config files is another key value store that is compiled into the Condor utilities library. This consists of about 2,000 keys. It is the defaults for everything in the Condor daemons and Condor status, and it's just lots and lots of stuff. In the submit file, there's a very small default set that is distinct. This is how Condor submit gets access to $cluster ID and $proc ID and $arch and opsys, for instance. All right. Config and submit files look like this. They have the pound sign introduces a comment. Everything else with an equal sign is a key assignment. Keys are case insensitive. So this will write the key log, and this line will replace it with, it turns out, the same value, because leading and trailing white space on lines are just removed. Lines that end in a backslash are continuation lines. That is, the very next line is, I skip ahead. The next line will be part of this value, and the next line will also be part of this value. And this was the result of some interesting bugs prior to Condor 8.2. If you had a comment line that ended in a backslash, then this next line became part of the comment. And so it didn't look, it looked like you were setting the knob, but the key value store did never see that line as anything. So in 8.2, we changed this. Comment lines that end in a backslash, that backslash is just ignored. And this, in this case, the frob bobulator knob will get set. The other way this showed up as a weird kind of bug is if you had a multi-line assignment statement with backslashes, so you were spreading your configuration out across multiple lines to make it more readable, there was this tendency or temptation to comment out one of the values. And that didn't work because the backslash, caused that pound character to just be treated as a value. And so we also have this specialized behavior. Lines that are part of a key assignment, the comment essentially forces that entire line to be treated as a hunk of white space. And the result then in 8.2 is that the list is ABD, not AB pound CD. So these are weird variations to the way the language works, but designed to avoid two different classes of common bugs that you face. All right. So inside this language, we have these things we call macro substitutions, right? The key value store, unlike class adds, where the right-hand side of a class add, the values have types, right? There are integers and there are strings. In the config and submit language, the right-hand side is just a blob of text. It has no meaning. But before it ever gets used, my mouse is advancing itself. Okay. Before it ever gets used, the system that does the lookup in the key value store is going to look for things that have the pattern $ open parens alpha numeric text close paren, and if it sees that, it will look in the hash table for that key and substitute whatever it finds. It's just a text substitution. There's no understanding of anything that's going on here. Also, remember that when we do key assignments, white space around the equal sign and after the last the last character in the line are removed. They never even make it into the hash table. And so here $sbin is going to be substituted with the value xbin. And if this isn't defined, then this will just get substituted with empty. There'll be nothing there. Substitution happens at lookup time. And for most of these values in the key value store, particularly for Condor submit or the config language, lookup time is runtime of the daemon or the time at which Condor submit is building the class add. That is, it's after we have constructed the entire key value store. The exception to this is if statements and well, basically any statement, anything that isn't a key value store. I'm talking ahead of myself, I'm sorry. The other point to this slide is that circular references are detected at runtime. This keeps happening. And eventually will cause whatever that's reading this, whatever's doing the lookup, to abort. Right? It'll just reference circularly until it gets to 1,000, and then it'll finally say, yeah, this is never going to stop, and it just kills itself. For the dollar substitution, you can have a default value. That is, if there is no value for the key, then what we do is substitute this literal value, whatever is after the colon, explicitly. So in this case, num CPUs will substitute either the current value of num CPUs or the value 2. All right. Now there's no schema in this key value store except one that is imposed by whoever is doing the lookup. And for most situations, there's a sort of default behavior. If the entity doing the lookup is expecting to get a number back, then it will evaluate whatever is on the right-hand side, hoping to get a number from that evaluation. And so this particular thing actually works, right? This will get parse as a class add expression. Split will turn this into an array. Size will say the size of the array is 4, and the result of this is it evaluates 4. For things that are expecting to get back a string and not a number, they typically just use the value unevaluated. And so this doesn't work unless your executable is strcat and accepting really weird arguments. I don't remember exactly when we did this, probably 8.6. We added multi-line values. So we started using configuration language more and more to express things where we wanted the value to be an entire class add. And class adds, while they can be expressed on a single line, it's kind of a pain. It's much neater if we can express them as multiple lines. And so you can now do key @ equals and some arbitrary tag, and then a bunch of lines. And then as soon as the line begins with @ tag, that ends the value. This is used for embedded user map data. It's used for job transforms. There's not a lot of use cases for it, but more and more all the time. As we have this capability, we use it. Also, wherever you can do a dollar substitution to do a lookup, we have these things called substitution functions, where you do dollar function name and some value, and it does some sort of lookup, but also something else. There's about 10 of these. One of these is $inv, which takes the name and treats it as an environment variable. Now, for historical reasons, if the environment variable doesn't exist, it wouldn't print nothing, unlike $regular open paren. It would print like literally the word undefined, which isn't very useful sometimes. But the environment substitution does also allow the default syntax. So you can say $inv name : and so if you do name : nothing, that is how you expand an environment variable to nothing when it is not defined. Here's some other substitution functions. The first two are particularly interesting, especially the first one, because this does the lookup, $int does the lookup, and then it also evaluates. So it does the lookup, takes that thing, runs it through the class add evaluator, hoping to get back a number, an integer. And then it prints that number as the substitution value. And you can specify a printf style format specifier as a means of printing that number. You can do some interesting things here. Keep in mind that the format specifier includes things other than %d. You can have constant text here. And so everything after the comma constitutes the part of the format specifier. The same for real, except real is floating point numbers, what expecting. $choice is interesting. It evaluates key, hoping to get back a number, and then uses that as an index into the second argument. If the second argument is a single argument, it assumes that that is a list. If there is more than 2 arguments, then it assumes that these extra arguments constitute the list. This is particularly useful in submit files. If you do something like Q3, then you can use that iteration number for Q3 as the key, and then specify the items as the values, as the lookup. And then the last one, my personal favorite, $F, which is take this thing, pretend it's a file name, and do file name chopping on it. So FP says print the path part. FD says print the directory part. X is the file extension, and so on and so forth. These last three is print with Unix path separators, print with Windows path separators for W, and then Q and A are quote the resulting value. Q is double quotes and A is single quotes. And this makes sense if you live inside my head. All right, I'm running out of time. And so I'm going to do just one more slide, and then I'm going to skip to the end and I'll give you guys a chance for questions. Inside these, the limitation of the class add language. Inside these $function substitutions, you would like to be able to do something like this. $int is $a plus 1, but that doesn't work because of the way the parser for this works. When it sees this pattern, it doesn't substitute anything at all. It just thinks that's not a substitution. If you put a $, goodness gracious. No. If you put a $sign inside these parentheses, you just prevent substitution. And so when you want to do this more complex evaluation, you typically have to use a temp variable. You put the expression in a temp variable, you $int using the name of the temp variable, right? It's ugly, but this works. And this works at a lot of different places, particularly useful in if statements, when you want to do some complex evaluation as the body of an if, because our if statements in the config language only allow simple ifs. You can do if true, if false. There's a special case for version comparison, and that's better. All right, I'm gonna skip way ahead because there is one thing right at the very end that I want to show you. This. If you learn nothing else from this talk, Condor config val - summary. This is a printout. It reads the config, and then it prints out only the values that differ from the defaults. It's just that simple. If you want a summary of the configuration of your system, this is it. It also understands that you are probably saving this or sending it to us so that we can reproduce your problem. And so it also prints the Condor version, just to be helpful. The other interesting thing that I want to point out to you is that different daemons potentially have different views of your configuration, particularly if you have changed the configuration since the daemon was started. And so you can use Condor config val to ask the daemon what its current hash table looks like. That is Condor config val -schedd says, please daemon, right, locates the schedd, and it says to the schedd, please give me your entire hash table. And if you pass -verbose, that will be annotated. It will actually have file and line number annotations for every line. And then there's a variation on this, which is Condor config val -subsys schedd, which doesn't talk to the schedd. What it says instead is read the config file as if you were the schedd. Now, if you have a simple config, this will be no different than the regular Condor config val output. But if you're using some of these advanced tricks, the schedd's view of the config files will in fact be different. And this can be useful in these pools that are doing interesting things. All right. I'd like to thank the NSF and give you a little bit of time for questions.